In this part, we're going to talk about the link between emotion and cognition. And although we've talked about decision making, we've kind of done that somewhat separate from the actual emotional impact and how emotional states may actually affect different cognitive processes. So that's really a core question, right? How do our emotions influence our thinking? How do we learn from emotional events? How do we remember emotional events? If you think about 9/11, for example, is that somehow significantly different in our memory system than less emotionally charged events, and so forth? Now, historically, there have been two different perspectives about the link between emotion and cognition. One way of looking at this is that, well, first of all, they've been considered separate domains, but the question is it possible for emotions to happen without cognition? And is it possible for cognition to happen without emotion? And the two positions are that either they're independent from each other, and one of the main proponents of that has been Robert Sayong, or another way of looking at this, proposed by Lazarus, is that emotions actually depend on how we cognitively appraise whatever stimulus it is that we're trying to process. Now, if we look at those two positions, the first position has become increasingly more improbable because, for example, if we look at links between the amygdala, which is the center for emotional processing in the brain, and other parts of the brain, even the visual cortex, where visual information is being processed, we see that even there are bilateral connections. So the amygdala connects to the visual cortex and influences it. The visual cortex connects to the amygdala and influences it. So there seems to be definitely some dependencies there. They interact with each other when we make decisions and when we process any cognitive information, even at the level of basic visual perception. Now, let's distinguish between emotions and some related terms such as moods and so forth. So emotions are pretty specific. They're relatively brief in nature. There's some synchronized response from our bodies, our faces, the way we subjectively feel, and they indicate an evaluation of an internal external event as significant. So something happens, we have a direct and brief response to it that involves both increases or decreases in heart rate, blinking rate, sweating, all of these kinds of responses. Moods are different because they are lower intensity and relatively of longer duration. So you can just wake up and happening to be in a happy mood or a sad mood, or just depending on how you feel that day, that's different from an emotion because it's not really triggered by any particular stimulus. It's more of an overall feeling, and because of that it's also lower in intensity and it's of relatively longer duration. Attitudes are yet different because those are really longer lasting dispositions, how you really feel about things, how attitudes color your beliefs, your preferences, predispositions towards objects, people. Those are attitudes, and they're relatively long lasting. And in some ways, they're also more cognitive in nature. And then there's motivation, which is really the propensity to take action, which is an important component sometimes of an effective response. When you have a response to something, of course, then there's a question of whether you're motivated to do something or not. And depending on that motivation, of course, you can then decide on a course of action. So that's some basic distinctions between these four terms. So emotions relatively short and specific to a stimulus, moods more longer lasting, attitudes real longer lasting predispositions, more cognitively impacted, and then motivation as a drive to actually do something. We also know that there are some really basic emotions that people across the globe share with each other. There are 6 of them, and those were first discovered by a famous researcher by the name of Paul Ekman, and he's done a lot of work on facial expressions, recognition of facial expressions, the link between facial expressions and emotions, and so forth. The 6 basic emotions are anger, disgust, fear, happiness, sadness, and surprise. And let me show you them to see if you can recognize this quickly, and I'm sure that you can. So for example, here we have a first one. It looks like anger. Here we have fear, happiness, surprise, sadness, and disgust. And what's interesting about these basic emotions is that you can look at those in a couple of different ways, but even if you look at the level of muscle contractions in the face, these 6 basic emotions differ from each other in a very particular constellation of which muscle contractions they actually involve in the face. So each of them has, different contractions around the eyes, around the mouth, and so forth. And that really expresses what the emotion is. These expressions are universal. Of course, those 6 emotions don't cover the full range of emotions. There are much more complex emotions that are not as primarily rooted in our facial musculature. But these 6 are clearly expressed by our facial expressions. Of course, there's emotions that are not clearly expressed by facial expression. So for example, love or guilt are much more subtle in some ways, and they are not as clearly pinpointed by linking them to specific musculature in the face. If we think about the different emotions, there are some main models that help us how to think about where these different emotions fall. And the first model is what's called the circumplex model. Now, a circumplex is a word for a circle. And in that circle, there's 2 axes. There's the axis of arousal, so how many bodily changes are occurring during an emotional episode. And then there's valence, which links to whether something is positive or negative. If you then put these 2 characteristics against each other as 2 axes, you can then group or position actual emotions relative to these 2 axes. And here's an example of how this plays out. So you see here the arousal axis, so either deactivation, you're not aroused, or high arousal, and then valence going from unpleasant to pleasant. And you see here that then you get this circumplex, this circle, where different emotions fall along different points on that circle that is being created. So for example, disgust is an unpleasant emotion with some arousal. Anger is higher arousal. Fear is higher arousal yet. Surprise is neither positive or negative, but has high activation. Happiness has relatively lower arousal, but obviously pleasant. And then down here you have the emotions like lethargic, calm, relaxed, fatigued, and so forth. So this is one prominent way of just thinking about how emotions can be classified along just 2 simple axes, an axis of valence and an axis of arousal. The second model is what's called the approach withdrawal model. And what's interesting here is that people differ in pretty fundamental ways in their tendency to either approach situations or to withdraw and avoid them. So in many cases, behavior that people opt for is driven by people's propensity to tend to act or not act on this dimension. There's some people who like to stop, drop, and roll. There's other people who like to approach. So there's a lot of research, some of it by Richard Davidson at University of Madison, Wisconsin. He has shown that people differ in their baseline tendencies on this dimension. And so that some of you will be more approach-oriented, some of you will be more withdrawal or more avoidance-oriented. And what's interesting is that they've actually done studies in infants where they take measurements from adult brains or infant brains. Let's first talk about the adult case. What you can do is put an EEG on them and just measure resting state activation in the left hemisphere and the right hemisphere as they're just sitting, not doing anything at all. And what you see is that most adults have an asymmetry in their resting state EEG activation. Some of you have a higher activation in the left hemisphere at rest. Some of you have a higher activation on the right hemisphere at rest. What they then did in this study is that then also they had people fill out a well-known measure called the Positive and Negative Affect Scale, or PANAS, where basically you get a measure of how high people score on positive affect states and approach type of measures, and negative aspect or withdrawal type of measures. And what they did is that they then linked people's scores on those tendencies and correlated them with whether they had higher left hemisphere or right hemisphere resting state EEG measurements. And interestingly enough, is what they found is that those with higher approach traits, so those who scored higher on the positive part of the PANAS, showed greater EEG activity in the left anterior frontal lobe at rest, and those with higher withdrawal traits showed higher activity at rest in the right anterior frontal lobe. Interestingly enough too, they have repeated those studies with infants, and there, of course, rather than having them fill out a questionnaire, they ask parents about their behavior, like how much do they tend to whine and fuss and so forth. And what they found there is that you find the same link, that there's a right dominance in their EEG resting states for those who tend to fuss more compared to those who are left dominant.